This is a JEE mains, no, sorry, JEE advanced problem. Okay, so you have a pretty standard problem where you have a ladder that is leaning against a wall, where you have friction coefficients and everything. And it's given that it's in equilibrium, so that's good. We can just equate the forces and say net force is 0, and it's about to slip. Think about it for a while. Why do you think they would say it's about to slip? It's actually given to help us. And the reason, this is mu1, okay, this is 1. I messed up the numbers earlier. This is 2, okay. So this is mu1, n1, this is mu2 and n2. Anyways, they have given that it's about to slip, and the reason they would do that is because the frictional forces would be maximum when it's about to slip. That's why. And what we need to do is, we need to check whether these things are, I mean, this is a more than one options correct question. And we need to check whether these guys are true or false. We need to see which of them are true. One of the most annoying kinds of problems you can get. Alright, so we will build equations and they'll plug in these conditions and just see which ones are right. So let's begin. So let's start by drawing this thing, like a rough drawing over here. This is a ladder over here. And let's quickly write all the forces down. There's mg, it's going to act over here. There are frictional forces, which I will use red. Friction over here will be upwards, and the friction is maximum. So that's going to be mu1 times n1. This is n1. And here is n2. And friction over here, let's see. The ladder is about to slip this way, so the friction will be in this direction. And that will be mu2 times n2. These are the only forces. Yep, these are the only forces. Let's quickly build equation. We will say net force in y must be 0. The upward force is n2 and mu1 n1. So n2 plus mu1 n1, that must be equal to mg. Okay, that's equation number 1 for us. Then we have second equation that we will build using sigma fx equal to 0. So horizontal forces, we have left one is n1 and you have a right one is mu2 n2. So n1 plus mu2 n2 must be equal to 0. That's problem equation number 2. And we need a third equation to bring in theta into the picture, and that happens by using torques. Let's take torque about this point. I like to take a point where there are maximum number of forces acting, so that those forces do not contribute to the torque. These guys, I could have taken about this point also. You could have chosen about center of mass, but then you'll have 4 forces putting the torque. And you could also calculate the torque about this point, and then you would be very daring and also stupid. Alright, so anyways, let's do it. So torque about point A would be equal to 0. These guys do not produce any torque. mg produces a torque, and let's see how much is the torque due to mg. It's going to be the force multiplied by the perpendicular distance from the point. So the perpendicular distance will be yay, this much. To calculate that, we need to know the length of the ladder. So let's call the length of the ladder as 2L, and this would be L. Let me write it down. I can't write it down, okay? Just put this in your memory. This is L. So this would be the adjacent component, that's L cos theta. And notice that the torque is clockwise. So I'll call clockwise as positive. I'm going to call this as positive. Alright, so clockwise torque, that's going to be mg times L cos theta. Okay? Then, who else is going to produce a torque about A? This fellow, N1. Is going to produce a torque this way. So that's going to be a negative sign. So it's going to be N1 multiplied by, look, this is the force. Perpendicular distance is just this length. It's just the length of the vertical wall. Over here, this one. And that's going to be 2L sine theta. It's the opposite component, 2L sine theta. So there's a 2L sine theta. Then this fellow is also going to contribute to my torque, and that's going to be again in this direction, the opposite direction. So minus mu1 n1, and the torque produced by this force, perpendicular distance, that's 2L cos theta. And that's going to be 0 as well. Notice that everywhere L cancels out, so L goes, so that's never going to bother me. So my equation now is going to be mg cos theta minus 2 n1 sin theta minus mu1 n1 times 2 cos theta equal to 0. That's equation number 3. And what we have to do now is substitute these various values that we have been given here and check whether these things are true or false. Okay, let's do that. Now to make this presentable, what I will do is I'm going to rewrite these equations and then we'll keep referring to these equations. So let me rewrite it over here quickly. Let's look at our first condition. Our first condition is mu1 equals 0 and mu2 not equal to 0. And we have to check whether this guy is true. So let's do that using glue. So let's put mu1 equal to 0 in the first case. Mu1 equals 0. If you put mu1 equals 0, nothing interesting happens over here. But something interesting happens here. N2 becomes equal to mg. So N2 equals mg. And over here we get N1 equals mu2 times N2, which is, sorry, this is a plus sign, and that equals 0. And since mu1 is 0, this guy disappears, this fellow is gone. And what we now end up getting is mg cos theta minus 2n1 sin theta equal to 0, because this fellow is gone now. We have to see whether we can derive this n2 tan theta. Alright, so to get tan, I'm going to divide the whole thing by cos. So mg minus 2n1 tan theta equal to 0. So I will get n1 tan theta as mg divided by 2. And that is an n2 tan theta equal to mg divided by 2. And that's not it. So this is wrong. But let's check if there are any other. Yes, we have. N1 tan theta equals mg by 2. That's right. This is correct. Okay, but we have other options to check as well. We have to check now what happens if mu1 equal to 0. Let's see. Can we do that? Over here somewhere. Let's try over here. We'll put now mu2 as 0. Sorry, we're going to put this one. Mu2 as 0. What happens to our equations when you put mu2 as 0? Well, n1 goes to 0. And nothing happens over here. Oh yeah, something happens. n1 is 0, so n2 becomes mg. And this guy, since n1 is 0, this whole thing disappears. And we end up with now mg cos theta is 0. We get something very weird. We get theta is 90 degrees, by the way. And I think that makes sense. You see, if you make mu2 equal to 0, then there's no friction here. And if there's no friction over here, there's no one countering n1. Therefore, n1 has to go to 0. And if n1 goes to 0, then there's no contact here. That means even this friction doesn't make any sense. So, yeah, obviously. So this is wrong. This is wrong. You don't get this equation. And now you have the last one. We have to check whether, what happens if mu1 and mu2 are, neither of them are 0. What happens then? I think that's the worst one to solve. plus we'll have a lot of algebra in that. Let's try solve it over here. That means we have to solve these equations. Are you ready for this? Let's do it. Okay, what we will do is we'll take this guy and substitute over here. So n1 equals minus mu2 n2. So let's put that. n1 equals minus mu2 n2. And let's put it over here. You will get n2 plus mu1 times n1, which is minus mu2 n2. That goes to mg, which means we get now n2 minus mu1 mu2 n2 equals mg. So hey, I don't think this is that bad. I think we got it. Oh yeah, we got it. 1 minus mu1 times mu2. And let's see, that's what we have. n2 equals mg divided by 1 plus mu1 mu2. That means this is right. So we have solved 2014 advanced problem. Stay tuned for more.